Okay, well, thank you, Brad. I appreciate it. So there's a lot of folks here who are familiar with PSP and TSP, and for you, it's going to seem a lot like a refresher course on planning. What's important here is that when we developed TPI at NAVAIR, we tried to change the focus so that it wasn't on software development, because we got a lot of pushback from our teams who weren't developing software. We have an example later on in this module that uses the development of test cases as an estimation. Not only have we used this on that sort of work, software development and everything else, we've also successfully applied this to a test team who estimated their work, the amount of time it was going to take them to actually complete the testing for their software, testing duties. You would think that planning was a popular activity. We would have thought that, and we would have been wrong. There's a lot of organizations, they all are promising to deliver on cost and on schedule, and their plans are cursory at best. If you really want to deliver a good estimate as to when your project is going to be completed and how much it's really going to cost, you've got to have a detailed plan. You have to be able to measure that plan as it's being executed, and you have to be measuring it at a detail that's useful to everybody. So when we teach the TPI to the folks here and coach their teams, we heavily emphasize the first point: never make a commitment without a plan. The answer is, you want this work done? You'll give us 2 weeks, we'll come back and we'll give you an estimate as to how long it's going to take to get it done and how much it's going to cost. If you want to make changes to this plan, this is pretty significant, we're going to need you to give us a couple of days to go back and replan so we can tell you what the effect will be. So additionally, the people who are going to be doing the work, they need to be doing the plan. It's not that management, are not competent, that they haven't done this before, but they may not have actually done this sort of work in a while. They might not understand what's available to complete the work, and they need to be out of the way and allow the teams to do that kind of planning. Does that work? After a couple of iterations on TPI teams plans where they're actually delivering what they said when they said they were going to deliver it, management will often step aside and let them do all of the planning, and in fact defend their plans up to higher management. So that's great if you know what you're doing, you've done it over and over again. Well, if you're in an area where you're new and you're not sure exactly what you're doing, you just plan fairly frequently. You remember the technique is to plan maybe 3 to 4 months of a long project in detail, and you might find yourself in a situation where you really want to be planning on a monthly basis because it's all new to your team. We've had that happen with the development of a database. All right, plan at the level that fits your job. You want to make it so that you're not measuring everything every 15 minutes. You want task sizes between 2 and 12 hours so that you get some useful data out of it, but you don't spend all your time clicking the mouse. And if the plan isn't working, you've got to fix the plan. These are very all important principles, and I'm sure you're all familiar with them. And of course, historical data is very helpful. If you have it, if you have a place where you can't plan accurately, usually it's because you don't have historical data, and that can be an issue, but it's easily overcome if you follow these principles. So we have the process. What do we do? We've been told to get some work done. How do we make a plan? Well, you break it down into bite-sized pieces, manageable chunks. You figure out what is it I have to do? What are the big parts that I've got? I'm going to estimate then the size of those parts, and from there I can estimate how much effort, how much calendar time it's going to take. And as you break those down, you can identify in general how large a project is going to be that spans 1 or 2 years. But for the next work cycle, say 3 to 4 months, then you're going to take those pieces that are going to be worked on immediately and break them into smaller pieces that you can track. And we'll talk about that a little bit later on by identifying the tasks within each of those the discrete tasks within each of those big pieces. And then the most important part, I think, is to figure out what your availability is to do the work. Everybody assumes that they got 8 hours a day to do their work, and that's just not really true when you're producing a product. So we'll talk about that as well. So here is our TPI planning framework. This should look familiar. Click mouse, please. First thing you're going to do is you're going to figure out based on the customer's need, what it is you're supposed to be delivering to them. You'll come up with a conceptual design, that is to say, what are all the big pieces that are involved in this project? And then for each of those pieces, you're going to estimate size and then the effort. Then you're going to take those ones you're going to work on immediately and break them down into smaller pieces using tasks that are going to be necessary to complete each of those big parts. From that, you can build your schedule, develop your product and services, and next click, you'll be then developing the product, or at least for the first cycle, developing the product, and then providing a delivery to your customer and collecting data all throughout this process on exactly how big the products were and how long they actually took you to complete them. Click, please, so that you can go back later on and do some analysis. We thought it was this big, and it was actually this big. We're off by some certain percentage. We thought it was going to take this long, and it actually took a little bit longer than we thought. So in future estimating, you can go back and adjust your estimates for the historical data that you're collecting. And this is the size and effort estimation, right? We talked about this, conceptual design, identify the big parts, and then give them some relative sizes, small, medium, and large. Then you're going to estimate the total size by adding up all those relative sizes to give you that total. And you're going to adjust that for your historical error. If you have that information, that will give you your total size estimate. Also, from the size estimate, you can come up with your effort estimate. You have some idea about what your availability is, and you understand for certain types of work, it takes a certain amount of time. I'll give you an example that I found to be true with technical writers, that if you've got to write on a topic that you must learn from scratch and then produce all the way to a published document, it's about 1 workday a page. Now, it's a workday, it's not task hours. So if you have in this example, if you've got a 10-page document, your estimate that needs to be written, your effort estimate is going to be about 10 calendar days to get that work done. Again, adjusting for error, and then you have your resource estimate. And so let's talk a little bit about each of those pieces now in greater detail. We're going to have, to help us along in this discussion, we're going to use an example where we had somebody who was developing test cases for a web-based shopping cart. So what do we need for our conceptual design? It's going to go through the requirements that are required for the product, and it's going to identify all of the parts that are necessary in order to meet those requirements. And then it's going to, once it's broken that set of requirements into discrete work products, then it's going to estimate the size of those products in terms of both how big they are and pages or what have you, and then how much time it's going to take you to get that work done. Lots of team member judgment involved in this one. And the team members, although they might at first think they can't estimate, they find pretty quickly that they're very accurate in their ability to estimate the sizes of the time it's going to take to get the work done. Here's our example. We have somebody who is going to develop test cases for the user interface, the business logic, and the database work that's necessary for this shopping cart we talked about earlier on. And we'll go through this to help illustrate how we go about the planning process. So we're here at this stage. We talked about size measures, both lines of code or pages of documents or chapters in a book. We've talked about how much time things are going to take. So we really need to just take a step back here and discuss what makes a size measure useful. And that is something where it correlates directly to effort. Watts Humphrey used for software source lines of code. We had other people who were using software decision points on the West Coast. So you have to find something that correlates to that effort. It needs to be something that when Brad measures it and I measure it, we get the same number. And it's very helpful, in fact, really required that it can be directly countable. So database screens, a number of times you're touching the database, that's directly countable. You can machine countable. So relative sizing. So the magic of the planning process with TPI is that it involves an innate ability of people to estimate how big something's going to be or how long it's going to take them. And oddly enough, when people do their estimating, it often seems to fall in line with standard deviations. So let's say Brad is digging ditches and he'll look in the yard and say, I've got to dig these many ditches. And he's going to say, this is a typical job, or this is, oh my goodness, this is huge, or it's one trench, it won't take me very long. When you collect all that data and you look at it, you find that, Brad's medium is, typical job is going to be a medium, as almost as if his brain has been collecting data for all these years on ditch digging. And a large one is going to be one standard deviation greater. So we've got that's lovely. Brad's estimate is probably going to be pretty good if he just looks at the yard and says, I got to dig a bunch of ditches. But Brad can actually improve his estimate if he increases, he breaks that big pile of ditches into, I have to dig 15 ditches that are going to be 7 medium ditches and 3 really long ditches and 1 very small ditch. As you break that down now, none of Brad's estimates will be right on the money. Some will be a little bit longer, some will be a little bit shorter, but on average, it should fall right onto into Brad's estimating ability. Give you an example. James Surowiecki wrote the book, The Wisdom of Crowds, in 2004, where they had 56 people estimating the number of jelly beans in a jar. There were actually 850 beans in there. The average guess of those 59 people was 871 beans. So when you break these projects down into smaller and smaller pieces, it's easier not only to guess the number of beans, but the average of those guesses, some high, some low, are going to bring you right down to what the actual, or very close to the actual number of lines of code or pages or hours that you're estimating. So in the jelly bean experiment, they were only off by 3%. This doesn't just work with jelly beans. In 2015, 17,000 people answered an online poll wanting to know the weight of a cow, and they were off by 5%. In the 1800s, a gentleman who was a mathematician assumed that people who were also college-educated gentlemen would be better at estimating weights than the hoi polloi. And so he ran an experiment where the hoi polloi absolutely thrashed the educated college gentleman and came up with far better estimates. So smaller pieces and more guesses, and that's a good thing. So I see a question in the chat. Do we use lines of code as a measure? For the software development teams, yes, often lines of code are used, source lines of code. The tool that we recommend using for work with TPI is the process dashboard produced by David Tuma and Associates, and that has a line counter built into it. Some teams have created their own line counters, or they've gotten a commercial line counter and use those. What really matters is that when they're doing their line counting, that that all the team members are consistent and use the same software. So we have now advanced on to the size estimate for our example today. And in our example, we have 10 user interface screens. We have 12 basic business commands that need to be tested, and then there's 40 times that the database is going to be touched by the software, and each of those has to have a test case. And in our example, the developer is 10 test cases for obviously for the interface screens. He's got 3 large, 5 medium, and 2 small. And probably we're going to be focusing on the interface for the rest of the example, but you can also see that he's broken his 12 business logic test cases down into 4 large, very large rather, 6 medium and 2 small. And similarly for the database interfaces, 10 large, 20 medium, and 10 small, all based on their gut feeling as to how long those are going to be. Complete estimate, 62 of these test cases. So we're talking about these, we sizes, small, medium, and large, and so forth, I'm depending on what you're doing, you're often using time measure, always rather, when you're doing the work. How long is it going to take to get it done? So what we're looking for really in a time measure, since that is ultimately what is going to come out to build our schedule, we want to measure only that time which is actually spent producing the product or designing the product or testing the product. We often have time on our professional days where we're having conversations or doing mandatory training or what have you, but we should not be counting that. So we want to focus on what we call, and I believe the SCI calls task time. And typically, if you're working on requirements or the design, you're doing your personal quality processes, testing the product and so forth, you're going to be measuring that one. What we don't want is measurements for meetings. If you have to take classes, we don't want you to include that in your task hours. Advice and assistance shouldn't be included in that. Hallway conversations, of course, and reviewing the sports events of the last weekend are not included. Now, I want to say something. We don't normally recommend that people count meetings in their task hours, but there is a couple of cases where counting meetings is important, and that is if management is pulling your development team into status meetings where they're spending, 20 people are spending an hour each. That can really cut into your work time for the week, and is not necessarily efficient. And if they have them help you more than one of those meetings a week, it can really slow the project down. So in those instances where the team or the team lead feel that they should get some relief from those, maybe send one representative to the management meeting, we then, in those cases, suggest that you record that time so you can report that to management at the end of the work cycle and ask them for relief. If you don't have data and you ask them to be let out of the meeting, they're not necessarily going to let you do that. But if you can bring data to the table and say, you're costing us 30 or 40 task hours a week across the team, here's our alternative, then with that data, they will almost always let you off the hook and say, instead of making everybody go, you get your one representative. So the question is, how many task hours are there in a 40-hour week? Mouse click. We know from data collected by the Software Engineering Institute that a software engineer who is very focused on their job can get about 15 task hours out of 40 task hours in a week. But that is for software engineering. We've been collecting data at NAVAIR, and other disciplines can achieve other levels of task hour. Click, please. Customer support. This is the performance resource team. We can often get up to 25 hours, task hours a week. But part of that, of course, is that we're spending time in the meetings that our teams are holding, and when they're not recording that as a task hour, that is actually a task hour for us and is important to record. Next slide, and what is the number of task hours for your job? That really depends on what you're doing. Team leads for a software team will often try to plan 12 to 15 task hours a week. We found that that's not going to work. Most team leaders for software development teams, for example, can really only get between 2 and 4 task hours a week. Subject matter experts. So it's your job, and it's also what your job is within the organization. Are you a subject matter expert who's always being asked for assistance and advice? Are you the person who is leading the team and you're interfacing with management and going to meetings and that sort of thing outside of that development of software? So we're now back to our estimate, our example here, and we have some historical productivity data from our example for the person who is doing the development or the test cases. And we can see that for the case of the user interface, that on average, he's got, it takes him 4 hours to do a large, 2 hours to do a medium, and 1 hour to do a small. So if he has 3 large, he's got a total of 12 task hours developing those test cases for the large test cases. And it's all very simple math. 5 mediums at 2 hours each. It's 10 hours, and 2 small at 1 hour per is 2. That all adds up to 24 hours total task hours. So you can't just start at 8 in the morning and work all night, and next morning at 8 it's done. It's going to be spread out over time. We'll talk about that in a second. So we've got, in our example, a conceptual design where he's broken it into user interface, business logic, and database manipulation. He's got sizes that he's estimated for each of those pieces, and he can derive an estimated effort overall based on historical data that he's had. So what do you do if you don't have historical data? You're going to have to use your judgment. You're going to have to use industry benchmarks if you can find it. So I mentioned earlier that we use this for development of a database. It was very difficult. None of the developers had actually done that work before. And when we searched high and low on the internet for industry benchmarks, we found there weren't any. That either they hadn't been recorded and published, or they just hadn't been collected. So this is the case where you plan early and you plan often. They replanned on a monthly basis, and over the course of a 6-month project, even though they had to use their judgment and had no historical data, they were still able to deliver the database within 1 day of their original estimate. That was by going back and every couple of monitoring it on a weekly basis and going back on a monthly basis and replanning the work. So basically collecting the historical data as they went along and working it back into the plan. So obviously the first month's historical data wasn't all that great, but it did get better as the project went on and they understood the work a little bit more. So I talked about breaking some of those larger conceptual parts into smaller sets of tasks. And we do that by defining the process necessary to complete that particular large-scale task in the conceptual design. And here is our process for that. I know you've all seen this before. We have our entry criteria, how to know when we can start. We have, for the example, we need to have test cases to address the normal functions. Then we have to address any abnormal functions. And there's some non-functional attributes, such as performance, security, and so forth. And then we have to address test cases for installation and configuration of the software. And then finally, how to know when we're done. Test cases are documented, time and defect logs are completed, and the process improvement proposals have all been written up and are ready to go to that committee. So you can see now we've develop a case, a large case, and we can break it into several discrete pieces: normal, abnormal, non-functional, and installations, etc. So let's see, overall estimate. There we have. I've just already spoken to this slide. So we've got now each test case development is broken into those separate functions and attributes and configurations, and then we can take the overall estimates of, say, 4 hours for a test case and break it into those discrete sections. So we'll know how long we'll be spending on normal functions. And here we are. From our historical data, we understand that addressing normal functions takes about 1/3 of the time for that test case. Same for abnormal functions, and then the other attributes and configurations take about 17% of the total time. So we've got this 10 user interface screens. We've broke it into 24 task hours, and we know we're going to be spending 1/3 of that time in abnormal. That's a total of 8 hours. So you can add that up yourself. Now we don't have just one task of 24 hours we're measuring. We've got those smaller tasks that we can measure against. Just a quick review of how the calculations are done. We have, for a planned value, we have for a task, it's the task estimated time divided by the project's total estimated time. So if you have a task that's 4 hours and the total time for that work is estimated to be 24 hours, and the planned value is basically 16.7%. you get no earned value until the task is completed. This is different from many planning processes where you get half of the value the second you start. We don't give you any value until you've already finished the project. And then when you finish the project, your earned value is actually equal to the planned value. You don't get any partial credit. It doesn't matter how long you took it to get it done, whether you got it done sooner than you thought or took longer than you thought, or you're right on the money, you get the same value. Your planned value is your earned value.
So Brad, or excuse me, David, you said finish the project. I assume you meant by that, finish that task, then you get all of the value.
That's right. Finish the task, sorry. And if you use planned value and earned value, then now you have a way of measuring where you are in your overall effort and estimating when you will be done. And so on our example, we have the task plan, we have the normal, abnormal, non-functional attributes and installations and so forth. You can see that they each in that column on the top, they have their task hours for each of those areas identified, 8, 8, 4, and so forth, what the planned value is for each of those. So for the non-functional attributes, it's 17% roughly. And we have the next column over talks about cumulative task hours. When we're done with the normal functions, we should have spent 8 hours on it. Abnormal functions, we should have spent 16. And then you can see the planned value on the right. By the time we're through the abnormal functions, we should be 66, 67% of the way through our task list. And then let's see, with schedule plan. We're now talking under plan hours, how many hours we think we're going to be able to spend a week on this project. So we're going to be spending a little over 2 weeks to work on it. The person who is the developer in our example gets 10 hours a week. And if all goes well, he'll have 10 hours done by the end of the first week, 20 by the end of the second week. And the project is not quite 30 hours. So somewhere about the midsection of week 3, this particular set of effort should have been completed. So we have our developer, and he's now in the 3rd week, and he has not gotten done yet. His normal functions took 10 hours instead of his estimated 8. His abnormal functions took 12 hours instead of 8. And he's in the middle of his non-functional attributes, and he's got 7 hours invested so far, which is a lot more than he thought they were going to have to spend on these projects. And this happens. It's okay if you go long, just as long as you know why, and you can account for that in your tracking of the work. So when do we think he's going to be? Clearly is underestimating how much time it's going to take to get the work done. When are they really going to be done with the work is the question now. And we have, for the explanation here, we're looking and seeing that his first week, he got 9 hours instead of the 10 he planned. He got 11 the next week and 9 the next week. Probably availability isn't the big issue for this person. It's a matter of really underestimating how long it's going to take him to get the work done. End of work week 1, hasn't gotten anything completed, so he has no earned value. He's got a third of his earned value by the end of the second week. By the end of the 3rd week now, he's got about 67% of the work completed. And he has to tell the supervisor how much more time to expect in order to finish this. So obviously, no credit for partially completed work. We find that over the course of 3 weeks, our developer's gotten 66.6 earned value. And the key is that he's accumulating 22.2% earned value on a weekly basis. He's done 66% of the work. So there's 33% of it left to go. At the rate at which he's been accumulating earned value, 22% per week, he's got about a week and a half left. A very simple calculation, but very, very powerful. So added to the 3 weeks he spent so far, he's now going to take about total 4.5 weeks for completing this particular work. And that's just for the interface. He'd be a week and a half late. This is interesting. At this point, the developer should be preparing to re-estimate the work for the database manipulation and the business logic, because he has a historical track record of underestimating how much time it's going to take him to get through his work. All right, so some considerations. The more detailed your plan, the more precisely you can measure your status. The better you can measure your status, the more accurate your projections as to when you're going to be completed. And you want to be as accurate as you possibly can. So that means digesting your work down into reasonable sized pieces. Typically, let's say you're going to get about 10 task hours a week. You want your tasks to be between 2 and 12 hours so that you can get something done every week. Okay. Interesting there's a question that somebody asked earlier today: how long does it take to get these plans completed? And the answer in short is that the more practice they've had planning, the less time it takes. And if you add into that some pre-work that they bring to the planning session, then they can take even less time. But we've had a plan to develop a camera on a test stand that was for use out on the ranges, where it took the team, had a very detailed set of requirements. It took them 3 weeks to get the plan out. But over the course of a 4-year project, they delivered within a month of when they thought they were originally going to develop, because they'd broken that set of requirements down into smaller and smaller sizes of tasks, and then they monitored that quickly. They knew where they were, carefully rather, and they knew when they needed to spend a little more effort to get caught up, when they could just sail along comfortably, and they did very well. The teams that Brad and Christiane are coaching have done this for a while. They do a lot of pre-work, and 3 half days typically gets the planning for the next work cycle complete, and they deliver what they say when they say they're going to deliver it. So you want your team members to know how to do basic planning. As I said earlier, you'd think that planning was a common skill and popular, and it is not. So we have some courses we teach here at NAVAIR on the team process integration, and we have a document that's available, a technical publication from NAVAIR from 2018 called the Team Process Integration and Overview. And I believe that Julia has a PDF copy of that if you would like it. I think she can distribute that to you as well. It gives basically an overview of the entire workshop this morning in text form. Your team members need to make detailed plans. Try not to have any tasks over 10 hours. Record task time daily and measure your earned value on a weekly basis. If you do that, you will have a team-wide understanding of the plan, and you'll be able to tell your customer within days, or in some cases over years, within a month, when you can expect the product that you're going, that you're paying us to develop. And the message is, the people that are doing the work must do the planning. You've got to have a framework, because historical data needs a consistent planning process to be useful. You need to have a framework for your planning. Our framework involves coming up with the overall idea about what needs to be done to accomplish the task, the conceptual design, and then breaking that down into discrete pieces and estimating both the size and whatever measure you're using, whether it's lines of code or pages or chapters or widgets, and then estimating how much effort it's going to take, figuring out who's going to do what task, and then putting all that together to come up with a master schedule. And you're going to use size and task hours and earned value for planning and tracking. I have a quick caveat to all of this, and that is that you can handle vacations and sick leave by figuring out how much time you've got and then knocking 10% of that off, or by going in and actually establishing in your schedule when people are going to be on vacation. And if you're working at the the Naval Air Systems Command, do not assume that people are going to be fully engaged in their work from Thanksgiving through New Year's. That's a terrible idea because the place is practically a ghost town. All the civil servants are off enjoying vacation, and the contractors like Brad are busy in the empty hallways looking for things to do. Okay.